Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to Madam Irma. So I hope you are feeling well and stay healthy during this pandemic COVID-19. So first of all, I would like to say thanks to Allah Subhanahu wa Ta'ala for giving me this great opportunity to present my water reticulation project today. So basically, I have give I have got a task from the question to design the water supply by following the plan that have been given to the question from the question. As we know, in hydraulic we need to use all the engineering principles to calculate this. So in this project, I have using the Hardy cost method to calculate all for the iteration and the others. Okay, this is my table of content. So we go through the my layout. So as you can see, this is my layout. So I create two loop. As you know, the less loop, so the easiest way can we calculate. So the area here is the Q out. So I assume anti-clockwise is positive. So this is my designing pipe size. I designed the pipe. So all of the length I got from the AutoCAD. So I transfer the design to AutoCAD with the scale of 1:1500, and all the dimension I transfer into this table. So the diameter I use is 0.18 meter, and the pipe that I choose is HDPE or high density polyethylene, because it is good in low temperature impact resistant and excellent in chemical resistant, and the C value is 130. So 3.2 it shows that this is my water demand calculation. So in the plan shows that residential area, the place of worship, and kindergarten. So the single story house contain of 201 unit house, and 1360 is the water demand that I got from the table from the island. So I multiply this, then I will got the answer 273,360 liter per day. Same goes to worship, and same goes to kindergarten. So 55 is water demand, and I will multiply by 150 people, I assume, at the area. And the kindergarten also, I assume the student is 30 people, because this is just a kindergarten and not a primary school or secondary school, so maybe the student is not too many. So for the total water demand, I add total for all of this single story, mosque, and kindergarten. So I've got the total water demand lah. Okay, so the Q in is equal to the Q out. So the Q out for the draw of node is Q1 until Q10. So Q in is my same with the Q out. Okay, this is my water demand draw of node. So I calculate, for example, the Q1 water we supply to 24 housing. Q4 water we supply to 26 housing. For Q7 water we supply to kindergarten. So the total is 0.0328 meter cube per second. Okay, next we go through the determine design flow. When water is at peak, we just want to know how many water will be flow. So we calculate by using the formula that have been given to the island. So 2.5 times the total water demand here. So I will get the 0.082 meter cube per second. So this is the peak flow scenario diagram. This is the Q in, this is the Q out, all the nodes. So next I calculate for firefighting flow. Firefighting flow formula is fire risk plus total water demand. So I choose class D risk that have been given in the table. Then I convert to liter per day. That is 1,641,600 liter per day. And then I calculate number fire of hydrant to get the Q fire. So number fire of hydrant I took from the largest or the longest length of the pipe, and I divide by the 120 spanning. So I will got the 2 NOS, and I will multiply by the class D risk to get the Q fire. After get the Q fire, I can calculate the Q2, where Q2 plus with the Q out. The point of Q out is the farthest the farthest point I choose is Q3 here. So I'll get the Q in for firefighting flow. This is the overall reservoir total. Okay, this is the firefighting flow scenario diagram. So as you can see, the Q in for firefighting flow, fire flow is 3,599,100 liters per day. This is the QR that we calculate from the water demand. Okay, let's go to the Hardy cross method. So as you know, this Q is I assume from the Q in. So the Q in I choose is from the fire flow because this fire flow Q in is larger than the water demand, the normal one. So we choose the largest one, the highest one is used as the Q in. So Q in will be minus by the Q out or the Q out to get all this value. So as you can see, the Q in is 0.04168 meter cube per second, and it also exit this value. If we can edit this value and this value, we will get the same answer. So the Q in and Q out is balanced. So I'll use the assume flow rate that I assume I will use on the iteration. This is my calculation for constant K. The formula I took is from slide. This is the K and this is the Q that I assumed before. The negative, positive is depends on the direction. As you know, I assume the anti-clockwise is positive, so what direction is not follow it will be negative. So the H that I got is for the first iteration is already 0, but I still calculate for the second iteration to get the more accurate answer. So to get the correction value, I'm using the formula Q correction is equal to Q plus delta Q here that we get here. Okay, Q here plus it here, so we will get the answer. And as you know, this area is joining pipe. Since the looping is use the same pipe, for the loop 1 use this pipe and loop 2 also use this pipe. So this is the joining pipe. So CD, DE, EF, FE, ED, DC is the joining pipe. So the formula to get the correction value is different. That is Q1 plus delta Q1 minus by Q from the loop. So this is the iteration. Then I got the H0 0. So the corrected value for flow rate I took from this, the last one, iteration. So the correction. So next we go to residual head calculation. First of all, we calculate the HSL first. So before we calculate the HSL, we should calculate for top water level. The platform level that I have given from the equation from the plant is 52.40 meter. So I will add with 3 meter from the formula. I will get 55.40. Then I can calculate the HSL plus by 7.6, so I get 63. So the HSL I will calculate for residual head by using method 2 that have been calculated here. So the HO I calculate from the formula that I have given from the island notes, and the HF I took from the head loss from the iteration, and the H I minus by HO minus by head loss, so I get the answer. And the HSL I calculate here, the above. After that, we can calculate the residual head. To to calculate the residual head, elevation plan plus by H minus by HSL, and we will get the answer. So if the residual head is more than 76, then this is okay. So overall is all okay. So next is water tank reservoir design. So the information, the total volume usage that I've been calculated before is 8,572,860 liter per day. Then I convert to meter cube per second. This is my land area for reservoir, and this is my elevation that I've given. This is the proper design that I use for the tank is stainless steel, and the tank that I use is 100 for the length and 40 meter for the width, and the area is 2,400 meter square. And the tank depth I use is 3.1 meter. So we can calculate the TWL for top water level for the reservoir also. Since residual head or structural head have been given is equal to the bottom water level 62.40, so we added by the tank depth, so I get the top water level. So to get the overall capacity of tank that can carry the water is we multiply by area multiply by the tank depth, so I get the 7,440 meter cube. So this is my water tank reservoir design. So as you can see, this is the top water level, this is the bottom water level, this is HSL, residual, this is the elevation, this is where the water supply to residential industry. So that's all. So in the conclusion, I have complete my water reticulation project by determine the design flow, I propose the water supply reservoir and pipe network, and I also analyze the residual head for the proper pipe size. And for the project, I already solved the design flow for this layout with 2 loops, and the total water demand that I got is 0.00328 and 0.0082, and the peak flow. However, the QN that I use, as I explained before, is 0.041664 for fire flow. So that's all. Thank you. I hope you are always feeling well, madam. Thank you for teaching us. Thank you for giving a good support, good guidance. Assalamualaikum. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh.